6-7, which is the last section in the unit. It is also the last section in your workbook. So I don't have a workbook in front of me looking at the page number, but it is one of the very last sections. So look for 6-7 at the bottom, example, and then the examples page. We are talking about geometric sequences and series. So geometric sequences are when you are multiplying or dividing by the same number in a pattern. So you didn't know it, but you started doing this as soon as you learned multiplication. So things like 2, and then 4, and then 8, and then 16. Well, that's geometric because every time you're multiplying by 2 to get the next number in the pattern. Okay? Now, sometimes if you look at this example and it says, is the sequence a geometric one? It wants to know, are you multiplying by the same number to get to the next number? And you're like, well, I can do that with 2, 4, and 8, but I'm not sure about decimals. I'm not as confident in decimals. So what you want to do is, so I got your little note there, so make sure to make note of it. R is always the right number divided by the left number. So we're talking about two numbers side by side. So like if I look here, these two numbers side by side, it is the right number divided by the left number. So 1.45 divided by 1.22. To test if it is geometric, that should equal the same thing as whatever 1.68 divided by 1.45 is. Change my pen color here so that you can see what I'm talking about. If I look at these two numbers and divide side by side, they should be the same. So I'm going to go to Desmos. I'm going to check that out. I still have stuff here from the last video. So 1.45 divided by 1.22. All right, that's a crazy decimal, but we'll go with it. 1.68 divided by 1.45. All right, I'm done. These two do not match. Those decimals do not match. So not geometric. Done. But what about the second one? So 0.75 divided by negative 1.5, negative 0.375 divided by 0.75. Okay, so I'm going to test all 4 of them in Desmos. So okay, I got negative 0.5. Uh-oh. 7.5. Oh, okay. Let's make sure that the last one there is also the same. And it is. So the common ratio is negative 1/2. Because every time that I divided that, I got negative 1/2. So notice the second part of this example says, write the recursive definition for this sequence. Recursive definition is just this that I have over here off to the side. And you are only going to change 2 things, meaning you're going to write everything that I did over there, but the 2 things that are highlighted are the only things that change. So notice I am copying everything else down. A sub 1 means the first term, so first number. So in this example, it's negative 1.5. R, we just found, was negative 0.5. That's it. That's the recursive formula. So now when I look at that formula, I know that the first term is negative 1.5 And then I am multiplying by negative 0.5 to get the next number and the next number and the next number. So if I wanted that number right there, I would just multiply by negative 0.5. Okay. There's one other formula here. So we don't just have recursive, we have something called explicit. And personally, I like explicit better. It's a little cleaner, it's a little easier to understand. So this example gives us the recursive formula and wants us to write it as an explicit definition. So again, you're going to write everything, but you're going to change the two things that I highlighted. Notice that n minus 1 is an exponent, so it's real tiny. Okay, the first term is always the number at the top, but that's why it says n equals 1. And then this right here is always r. We just talked about that in the last example. So that is my explicit definition. What could I do with that? So what I could do with that is if I had some pattern that the first term was 12 and it was still going, and every time we were multiplying by a third, I could just plug in that number. So like if I wanted to find the sixth term, so the 1, 2, 3, 4, 5, sixth term over, I would just plug in 6 there and be done, which is kind of nice. Makes it a little easier to work with. All right, this one just goes the other, example B here just goes the other way, but same thing. You have A1, you have R, so you type this and then write this and then change A1 and R. That's it. Okay. Weird symbol alert. We did it in topic 1 back in August, but it's been a while. So remember that this symbol meant the sum of. And so what it says is I would find the first 5 terms, the terms 1 through 5 of this sequence, and then I would add them all together, because that's what sum is. And if you're thinking, well, I don't want to do all that, well, that's okay. That's what your calculator's for. So if you go to Desmos and you go to functions, you will notice under the miscellaneous tab, there is one of those symbols. From there, you type what is there. Okay. And I've already forgotten what. Here we go. I'm looking at it on my computer, so I don't have to go back and forth. Make sure to use the same letters. If I wanted that as a fraction, it would be 121 over 2, or a decimal would be 60.5 if I added all of that together. The n minus 1, if you don't have those parentheses there, and you try to do it, so n, and then I do minus 1. Notice it makes the minus 1 jump down. That's not correct. So in order to keep that minus 1 up there, that's why I use the parentheses, if you're wondering. Okay. All right, so easy enough. Type it in the calculator. Remember, this fraction is equal to this decimal, so that's the same thing. And then the last problem of the day, there is a formula to use if you are feeling up to it. If not, that's okay. So first thing we need to do is figure out, in this pattern, what is R? So we need to do negative 2/3 divided by negative 2 to figure out what R is. So negative 2 divided by 3, all divided by negative 2. Make that a fraction because I don't want to write that repeated decimal. That is 1/3. That is 1/3. So right? The next thing we want to do is figure out how many terms are there. There is a way to set an equation and solve, but I don't necessarily recommend it. What I would recommend instead is multiplying by 1/3. You can use your calculator to get the next term. And I did this already so that you don't have to see me go from Desmos back and back, you know, back and forth. So -2/9 is what I get when I multiply by 1/3. Then I take that answer and multiply by 1/3, and I get -2/27. I multiply that by 1/3. I get -2/81 times that by 1/3, and I get -2/243. I'm going to stop there because that's where it stopped up here. Now, how many terms is that? 1, 2, 3, 4, 5, 6 terms. So if I'm wanting to use this formula here, my first term was -2. R was 1/3. And then I need to raise R to the N. N is the number of terms, so that's why I counted out the 6 there. So if I want to find the sum of all of those numbers, I have 2 options. And honestly, if it were me, I'd probably just do this option. Type all this in your calculator and get an answer. Boom. But there is a formula. Someone has proved that this works all the time, and some people prefer it, especially if they're having to deal with a whole lot of numbers. Typing this in your calculator will also give you the same answer. That's why they're both green there, to tell you that by typing either one of those in the calculator, you're going to get the same number. And to save you a little bit of time, I'm going to go ahead and tell you that that fraction, because they'll give you some crazy decimal, should look like this when you are done. So this is the end of the video, but take a minute and try both of those things highlighted in your calculator and see if you get this answer as your final answer.